Hello and welcome back to CST 2120. So this lecture is on animation graphics, sort of mostly animation really, and obviously the main motivation for this is to help you with your kind of game coursework, right? You've got to write a game. A lot of games are kind of graphical, Space Invaders, Snake, Brick Breaker, all this kind of stuff. And so to build those kind of games, you need to be able to do animation with JavaScript. However, obviously there's a sort of broader sort of application of animation in JavaScript, which is all the kind of visual effects that you see in modern websites. So simple stuff like hovering over a menu and then you get a sub-menu appear, slideshows, transition effects, all this kind of stuff. It's all done with JavaScript animation. So to build modern web pages, you need to be able to use animation, even if you're not building games, yeah? So in this lecture, I'm going to cover CSS animation, then explain how the canvas works, and in the end, I'm just going to very briefly explain scalable vector graphics in web pages, which you're probably not going to use, but it's worth being aware of, yeah? Okay, so CSS animation. So there's two standard ways of using JavaScript for animation. We've got sort of manipulation of the CSS, HTML properties, etc., using document object model. And then we got the HTML5 canvas. So to start with, I'm going to talk about what I'm calling CSS animation, which is changing CSS properties to make things move and appear and disappear and this kind of stuff. So I've explained, much earlier in this lecture, in this module, how we can use CSS to position HTML, image, etc. at exact positions on the page. And you can also change things like, the color of text or the visibility, this kind of thing, the sort of layering, all of that can be controlled with CSS. And so with JavaScript, we can manipulate the CSS and change things like position, layout, visibility, and so on and so forth, yeah? Just check, yep, one sec. Okay, so each element has a style property. And the style property is an object, has all the different CSS properties, visibility, margins, absolute position, this kind of stuff, yeah? So in a simple example, we can get a reference to a paragraph and document object model, and using the style object, we can access properties like color, position, and so on and so forth, yeah? And change them dynamically with JavaScript. So with JavaScript animation, JavaScript effects, we typically don't want the effect to happen instantaneously, right? If we're having a car kind of driving along the road, we don't want the car to go donk donk, right? Straight away, move to the end of the road. We want it to appear at regular intervals, sort of appear to be moving. And when the illusion of movement is produced by displaying the object at one position and then displaying it at a slightly different position, and so on, so on, so on. Just like a cinema, right? In a cinema, if we want to produce the appearance of a ball rolling down the hill, just to pick a boring example. Initially, we show a frame with the ball at the top of the hill, then we show a second frame with the ball slightly further down the hill, and so on and so forth. By repeatedly displaying pictures with the ball at different positions, we get the illusion of movement because our brain sort of interprets that sequence of pictures as the moving image, yeah? Or, you've probably seen the kind of little sort of, when you're a kid, you probably made little stick men. You have like flick books for animation, right? Where you have draw a stick man at different positions in a book, and you flick the pages and you see the stick man, doing some kind of action like running, yeah? So same idea. So to make this work with JavaScript, we need timer functions, yeah? We need to be able to present the image once, and then 100 milliseconds later, we're going to change the image slightly, present it again, and so on and so forth, yeah? So two timer functions are set timeout, which we don't use much for animation, but might be handy in some contexts where you execute the function once after a specified interval. So timeout maybe we might use in a quiz game where there's like a limited number of the user has to make an answer within a certain response. And then we have set interval, which repeatedly executes the specified function after the specified interval. So if we, I think I've got some examples anyway, So those are the two types of timers in JavaScript. And sometimes we don't want the timer to keep going indefinitely. We might need to cancel the timer sometimes, like at the end of the game or something like that. And then we can use the two methods, clear interval or clear timer. So we've got interval timer that's going to execute a function every 1,000 milliseconds in this case. As long as we've got a reference to that, so instead of just calling set interval my function, we assign it to a variable. Once it's stored as a variable, we can then use clear interval to stop the timer, yeah? And again, the same true with timeout. We can cancel that timeout before it's executed by storing a reference to it and then calling clear timeout on it. Okay, so now we know how to start timers, which call functions repeatedly, and we know how to stop them. Now we can actually move on to some simple animation example. So I'll show you it first, and then we can talk about how it works. Yeah. So let's find it. So this is possibly the least exciting animation you're going to see. So here we've basically got a square that moves from left to right across the canvas, across the page, not the canvas, sorry. When it reaches the far right position, it then flicks back to start again. Yeah. So that's very, very basic animation. I'm just using to illustrate the basic principles here. So first, we need to set up the HTML element we're animating. So this is just a div. I've given it an ID so I can access it later. And I've done a bit of styling. So I've made it sort of square, 40 pixels by 40 pixels, made it red. And I made it position absolute so that I can control its position in the page exactly, yeah? So I've set up my square, and now I need to animate it. So what I've got here is is a position variable, yeah? And this is the most basic example of something that you're going to use a lot if you're writing games or in a lot of other contexts in programming as well. We're going to come to this in the lecture on advanced JavaScript frameworks as well, yeah? So typically with programming, when you've got a graphical display, you have what's called a model, and then you have a view, yeah? So the model is a sort of data structure corresponding in this case to the animation, or corresponding to the game, or if we were modeling the weather, it'd be some kind of data structure corresponding to the weather, yeah? So we have a data structure, the model, and then we have a view, which is a sort of visual representation that corresponds to the model. And then you often have a controller that enables you to interact between the model and make changes to the model via the view. But anyway, let's not worry about controllers now. We have a model and we have a view. So in games, you typically have a sort of data structure that corresponds to your game, yeah? So in this case, it's just a very, very basic data structure. We just got a single variable that tells us the position, the distance of this rectangle from the edge of the page. But if we were doing Snake, for example, we might have a data structure that like some kind of array that corresponding to each of the blocks, and within each point in the array, we'd have like the XY position of the blocks. So we'd have some kind of array data structure, whatever it is for Snake, and then we'd have some way of displaying that snake or drawing that snake on the canvas. And the two things are typically kept separate, and if they're not kept separate, you're probably in trouble, yeah? Because you're going to get in trouble. It's just a mess, yeah? So you typically have a model and a view. So in this case, we've got a very simple model, position. And what we're going to do is we're going to use the setInterval function to call this moveSquare function every 100 milliseconds in this case. Now what we're doing here to animate it is we're changing the model, we're changing the position, so we're increasing it by 10. And then we're correcting that if it kind of goes off the edge of the page. And then we're displaying, we're drawing the square at that position by changing the style element here, yeah? So we're changing the model, and then we're redrawing the model so that the user can see it and see the actual animation. Okay. So I thought, well, that's all very well, but let's go for a slightly more exciting example. So, if you're hang out at fairgrounds much, or, country fairs sort of things, you often see this kind of Splat the Rat or Whack a Rat game. Typically played, I must hasten to add, with artificial, furry kind of rats. But obviously the cruel people might play it with real rats, but, we're not going to go there. You play it with like a little sort of toy rat, right? You drop it down. And the idea is you sort of wait at the bottom, and then you try and hit the rat as it emerges from the tube. And obviously, it's tricky to do because you don't know the speed of the rat until you've figured out the speed of the rat down the tube. It's hard to hit it because it just sort of pops out very quickly, yeah, as perhaps real rats do as well, yeah. So do a quick demo of my sort of fairly basic implementation of Whack a Rat. So here we've got my Whack a Rat game in JavaScript. So we've got two buttons, one that drops the rat and one that whacks the rat, yeah? So I'll just show you the game a couple of times. So dropping the rat just animates the image going down there. It goes all the way down, then eventually it stops, when it kind of reaches the bottom, yeah? When it's safe, so to speak. And then Whack a Rat will make a baseball bat appear. And if that baseball bat coincides with the rat, then I get a feedback message, you hit the rat. And if we play again and try the baseball bat when the rat's not visible, then it gets you missed. So it's a very sort of basic game, but used just to illustrate this kind of CSS kind of animation in JavaScript. So I'll briefly explain how it works. So as a note, you've got access to the example code for this lecture. So I'll put that in there and you can have a look at it if you want to, adapt it and use it for your own examples. Obviously, if you just hand in whack a rat, we're not going to give you any marks, but if you take this basic principle and extend it to build your own game, that's totally fine. So I'm not going to go into the CSS, which you should be familiar with by now, or the kind of handlers. So we've got these button handlers calling the various functions to drop the rat and whack the rat. Not going to go into that, except to note that we're just using images here. I'm not doing anything fancy to draw that rat. I've just got a picture of a rat from somewhere else, and then I'm animating that picture in this here. So let's go into the code that's sort of more relevant here, yeah? So we've got we're getting references to the rat and the whacker. None of this is interesting. So then we got the position, which is our model here, and some basic facts about the rat length and the bat height, which we're using to judge whether the bats hit the rat or not. We've got a speed variable, which controls how fast the rat moves. So if you're doing levels, you could change the speed. And then timer, oh yeah, that's a reference to the timer, so I can stop it later, yeah? So the drop the rat function, so that's called when you click on the button drop rat, right? So it sets the position to 50 and then sets the style so that the rat will be at 50 pixels from the top of the page. It hides the whacker using the style visibility property. And then it resets the feedback here at the bottom. And then it sets the interval. So it's going to call the move rat function every 50 milliseconds. Now the move rat function checks to see if the position's less than 900, so it stops at the bottom, yeah. And if it's less than 900, then it's going to add the speed to the position, so that enables me to control how fast it moves down, adds the speed to the position, and just increases and sets that as the style property for the rat image. And if the position's gone all the way down, if the rat's at the bottom, then we just want to clear the timer and stop the timer so the rat stops moving. Whack rat's pretty easy. We're just setting the style property, the visibility style property to visible so that the bat appears. Then it does some very basic maths to check to see whether the bat coincides with the rat, i.e. the bat has hit the rat. And if it has hit the bat, then we stop the rat moving, yeah? So very simple, but just a slightly more elaborate example than the square moving across the canvas, yeah? Except it's not a canvas, yeah? I'm using CSS animation. Right, so next section, I'm going to cover the canvas. So what I showed you so far is CSS animation. We're changing the position of elements in just the same way we do any kind of CSS layout for the page, yeah? But what HTML5 comes with, which is rather nice, is this canvas. And that provides a much more, much richer environment, if you like, for doing this kind of animation. And in a way, it's easier than doing the CSS animation. So what the canvas is a rectangular shape that has pixels in it, yeah? So you've got a certain number of pixels across, a certain number of pixels down, and you change the color of the pixels to create images. Now, it doesn't have to be as low level as that, right? Because the canvas comes with a lot of drawing methods that we can use to draw arcs or shapes, possibly gradients. You can draw images on the canvas. So it's a sort of pretty sophisticated sort of space within which you can create lots of different kinds of animation, which makes it very suitable for creating JavaScript games. So with the CSS animation, you have to be a little bit careful to constrain your animation to the space, to one particular space in the page. Yeah, so it's fine if you've got a full page animation, but then you might have problems when the page resizes with, you probably have to prevent that if you're doing CSS animation. Because the CSS is used for the rest of the page as well, you have potential interference effects and problems with responsive websites and all that kind of thing. So CSS animation is nice, but it has, some potential issues that are easily addressed but have to be addressed. Yeah, put it that way. Now with the canvas, and also, sorry, you'd use CSS animation for sure when you're doing like transitions, slideshows, all that kind of JavaScript sort of dynamic web page effects. Now the canvas doesn't have those problems because you've just got an HTML element that you can set to be a particular fixed size, and then you just have like a scroll bar if the web page is zoomed too much in on it, which in itself could be an issue. So it's not perfect. The other problem with the canvas is it's just pixels. So if you zoom in on the pixels, you're going to see the pixels. Yeah. So if you draw like a letter or a shape on here, it's going to get a bit jagged if you look at it too closely, or if the canvas doesn't have high enough resolution. So canvases are easy to integrate into web pages, but they have some limitations of their own. Okay, so one thing to be aware about canvases is they sort of start at 0, 0 in the top left corner, and the Y values increase as you go down the page, not as you go up the page. So regular graph, Y increases as you go up. With a canvas, it increases as you go down, just like the coordinate system in CSS more generally, yeah? Okay, so let's start with most basic canvas. As I said, canvas is just an HTML element, yeah, HTML5 element. So we can give it an ID, we can give it a width and a height. In this case, I've got a border on it so we can see it. And there, behold, we have a blank canvas, right? And then we can put stuff in it to make our game. So draw on the canvas. We need a canvas, obviously, so that's the HTML canvas element. And then what I've got, so just as in any other HTML element, I can use the document object model to get a reference to this canvas element here. That's what my canvas is here. And here we come to the sort of unique features of canvases. So you don't sort of draw on them directly, because my canvas is just an HTML element, but because it's a canvas HTML element, I can get this context out of it. So context is a sort of an object linked to the canvas that we use to draw on the canvas. It's a bit like maybe a pen or something. Yeah, you have the canvas, and then you have something like a pen or a context that gives us the ability to draw on that canvas. So I'm only going to cover 2D context here, but there are, as I'll give you a couple of examples later, much more sophisticated 3D, stuff you can do with canvases. But we're just aiming at the basics here, right? This is, first term of JavaScript. We're not going to be doing 3D rendering and lighting, all that kind of stuff. Yeah. So we get a context like a pen or your hand, if you like, to draw on the canvas. And then with the context, we can set the color of the fill or the lines, that kind of thing. And then and it has a bunch of built-in methods for drawing rectangles, circles, arcs, lines, whatever you like, yeah? And you can even draw images as well using the context. So we use the context and the built-in methods associated with the context to draw on the canvas. That's how it works. So you always need to get a context when we're working with a canvas. So here we've got a basic showing you how you could draw a green rectangle on the canvas. Yeah. So we want to build a game, right? So in that case, we need to be able to handle events of some kind. Yeah, it'd be a kind of boring game if we couldn't interact with it in some way. So we can use keyboard and mouse events to control what happens on the canvas. So in an earlier lecture, I covered keyboard events. So you could try listening for keyboard events on the canvas itself, but that might get you into problems, yeah, because for the keyboard events to be processed, the canvas would need to have focus, yeah, and that can be tricky because canvases aren't really the sort of thing that necessarily have focus. So it might work, but you're probably better off listening for keyboard events in the window as a whole, and then channeling, and then processing the appropriate ones for your game as you need to, yeah. So like an arrow up. If it was heard at the window as a whole, you'd then process it in the game itself, yeah? Mouse events, though, can be triggered by the canvas itself because it's just like a mouse over event, which is, it doesn't matter whether the thing has focus or not. So I'll just show you how to do that here, yeah? You can refer back to the earlier stuff on keyboard events if you want to use keyboard events. Okay, so here's a little canvas and mouse example, yeah? So I'll just show you it, and then we can go through the code. Not that. Okay, so here we got the canvas, yeah, it's listening for mouse events. So when I move the mouse onto the canvas, it draws a purple square at the position of the mouse, roughly, and I'll explain why roughly, yeah? So that's all it does, but it's just showing you how to process mouse events for the canvas. So let's go into the code a little bit, and I'll explain them roughly as I go through the code. So the crucial thing here is we're listening for mouse events on the canvas itself. So the canvas has an on-mouse move event, and we're associating that mouse, we're handling that on-mouse move event by the draw rectangle function. So whenever this event occurs, it'll call the draw rectangle function here. The draw rectangle function will be called with this event object. So you remember with keyboard events, the event object that's associated with a keyboard event has control codes and all that kind of stuff. Yeah, we can know which key has been pressed. In this case, the mouse event has a bunch of mouse-specific data. In this case, the most useful of which is the client X and the client Y. Yeah. So the client X and the client Y are the mouse X and Y position. Now just take note, this is the mouse X and Y position within the window as a whole, yeah? It's not the mouse and X position, Y position within the canvas. So if we look at this example, it's actually offset by about 10, 20 pixels, something like that. It's actually not drawing it at the tip of the mouse, it's drawing it sort of about 10, 20 pixels to the left, bottom left of it's drawing it sort of slightly off, basically, yeah? Reason it's doing that is because the mouse X and Y position are absolute within the window, whereas it's the canvas whereas it's drawing it starting at 0 within the canvas frame of reference. Yeah, so we'd have to do this properly, we'd have to subtract the canvas's location in the window from the mouse X and Y positions. But anyway, it doesn't really matter just for this simple example. Yeah, so we're drawing a rectangle at location of the mouse event. And also the mouse event's going to going that way rather than that way, so that's also why it looks off. Yeah. But anyway, so these are absolute positions in the window, and then we're getting the position from the event object and then using that to draw a rectangle on the window. So obviously if we wanted some kind of game that involved sort of hovering over things and then maybe pressing the mouse button, this would be the kind of thing we want to do. Yeah, we could do, there's lots of sort of nice clever games that do this kind of thing. Yeah, you could like fly a spaceship with a mouse or something. Yeah. Okay, I think it's pretty clear. Okay, so showing you how to do basic animation, not with the canvas though, yeah? So I've shown you how to handle my events. So in terms of animation with the canvas, it's slightly different from CSS animation. Because with CSS animation, we're just moving a specific object, like an image or a HTML element or something like that, yeah? So we don't have, so we just put it in a different position, the browser re-renders everything, and that's job done kind of thing. But with the canvas, we're just drawing pixels, yeah? So to animate things on the canvas, we need to clear the canvas completely, and then redraw the image or whatever it is at a slightly different location. Otherwise, we're going to get a sort of tail of the previous images appearing if we don't clear them without clearing the canvas, yeah? So, let's do it with an example, yeah? So here's my little animation example. Actually, what I'll do is I'll show you it working properly, and I'll disable the clearing, and then that'll make my point more clearly. So here we've got the canvas. I've got a little sort of face thing. I'm sort of drawing that being animated, going from left to right across the canvas. Now, here, if I get rid of the clearing of the canvas and then redraw it, you'll hopefully see what I mean, yeah? We just get this kind of smeared out, blurry effect, because the pixels aren't changed when I draw a new image. I'm just drawing the same image again and again in different locations, and then that's all just getting smeared out like that, yeah? Whereas if I go back to the original, then we can see it appears to be like an animation thing, yeah? Okay, so let's go through the code a little bit. I'm not doing all the stuff I covered already. So we've got a set interval that's calling the animate function. And so again, we've got our underlying model of the position of the face, which is just the X position from the edge here. So we're just increasing that X position by 10 pixels every 100 milliseconds in this case. So that's dead easy. Now this is the bit that's new here, yeah? So what we've got is a method that clears the canvas, completely wipes it out. And then after the canvas has been cleared, it draws the face. So the workflow is we draw the face, clear the canvas, draw the face at a slightly different location, clear the canvas, draw the face at a slightly different location. In that way, we avoid the blurring, sort of smearing out of the face, and the face has this illusion of motion. So the clear the canvas method, in this case, because it's just a white canvas, just sort of fills it completely with a white rectangle. But obviously, if you had a background, you know, it'd be kind of boring game if you didn't have some kind of background, some kind of jungle scene or something, yeah, then we'd be drawing the image first as the background, yeah? So we draw the background stuff first, and then on top of that, we're drawing the face at the position determined by the X position, yeah? Now, this is just a very, I'm not going to go through details, this is just drawing rectangles to the eyes and nose and mouth, but just take note that even this very simple character is already kind of complicated. And what people often do with games is they have what's called a sprite sheet, which has a sort of picture of the character, has lots and lots of pictures of the character in different positions, and then they sort of shift that around to make the character appear to be animated. So, you know, if we want to do this sort of nicely, we could use a sprite sheet, have a much nicer picture of a face, and maybe as it moved across, it could open its and close its mouth by moving to different pictures on that sprite sheet. Yeah, just look at, you know, there's lots of tutorials and that kind of stuff. Yeah. So using that kind of basic animation, combined with a bit of keyboard events, combined with maybe drawing images, which there's lots of tutorials online about, you know, you can put together a basic game. You could easily put together some kind of Space Invaders thing where you sort of, you know, your animation in that case would be the bullet, would have a particular position, and then you'd have to check if that position equaled the position of an alien or something like that. Yeah. So to get your 10 marks for more sophisticated game, you know, you've got to put the time in and spend some time playing around with this JavaScript, the animation stuff, the keyboard handling stuff, and put together some kind of game that, you know, incorporates all those elements. And if you write that game yourself and it's a decent game, you can get the marks, yeah? Okay, so I'm just going to mention this scalar vector graphics stuff. I don't think it's that relevant, but it's part of the whole picture of animation and graphics. I'm going to mention it, yeah? So you can also specify, so I've shown you how we can use CSS to lay out stuff on the page. We can obviously use Inkscape to draw stuff and convert that to an image and create images on the page that way. But we can also create graphical elements on the page using scalar vector graphics, yeah? So with the canvas or with an image, you have a bunch of pixels, and the color of the pixels is, you know, is used to create the image. Yeah, you set the pixels to different colors, and then you get the image. With scalar vector graphics, it's more sort of abstract in the sense that you specify that you want to draw a circle, and that circle has a certain kind of radius and a certain kind of color and a certain fill and all that kind of stuff, yeah? So if you zoom in on an image or zoom in on the canvas, what you're going to see is pixels, yeah? It's going to get increasingly kind of blocky, yeah? If you zoom in on a scalar vector graphics image, it's always going to be, you know, beautiful and smooth because it's specified in a sort of more abstract language, yeah? So let's not worry about the details, but you can do all kinds of stuff with scalar vector graphics. So Inkscape itself is a scalar vector graphics editor. So anything you can do in Inkscape, you can, you know, pretty much do with this scalar vector graphics on a web page. Yeah, it's not used a huge amount of scalar vector graphics, but, you know, it has its place. So potentially, since Inkscape is a scalar vector graphics editor, you could sort of create graphics in Inkscape and then, you know, copy out the bits, you know, like for a rectangle, and then incorporate them into the page. But, you know, whether you want to do that is a little bit of an open question, I think. So this is, you know, the sort of differences here. So canvases, so they are resolution dependent because they're based on pixels, whereas scalar vector graphics will always look good. But the problem, what they mean here by no support for event handlers is that within a canvas, you just have pixels. You can have event handlers for the canvas as a whole, but if I draw a rectangle, then I can't attach an event handler to that rectangle. I have to handle it by having some kind of underlying model and using that model to determine if the mouse is within that rectangle or not, yeah? Whereas with scalar vector graphics, I can attach an event handler to particular graphical elements that I used to interact with. So in some contexts, for kind of slow games or maps or something like that, scalar vector graphics is the better choice, yeah? So yeah, Canvas probably better for games. SVG would work for games, but you'd have to, not for sort of fast ones involving lots of, you know, intensive graphics, maybe Solitaire or something like that. Card games maybe could work with SVG. So last thing I want to talk about here are JavaScript game engines. So as you saw with this very basic face example, it can take an awful lot of code to do, you know, to build a game with like fancy graphics with things that move up and down, because typically games don't just have one thing that moves because it'd be kind of boring. You typically have a sort of background things like, you know, moles popping out of holes or whatever it is, yeah. You have events that are happening on different timescales, yeah? And to write a sort of JavaScript game from the ground up, just using the canvas and context, would take a very long time to build a sophisticated game. And for that reason, quite a few people have built JavaScript game engines. So if you're doing a professional game that's got sophisticated graphics, rendering, maybe 3D, something like that, you know, you'd be a bit crazy to use, you know, basic JavaScript in the canvas. Your starting place would rather be a game engine, yeah? And so a couple of the popular ones are Phaser and Babylon. So if you want to build, let's say a sort of 3D adventure game or something like that, then you could use JavaScript to control the game engine and configure the game engine to produce the environment, and then the game engine would handle things like lighting and gravity, that kind of stuff. And then on top of that, you could build your more sophisticated game. So yeah, if I was a professional, first thing I'd go for would be a game engine. I certainly wouldn't dream of building a game from the ground up using JavaScript and the canvas. But in your projects, probably not the best idea to use a game engine, yeah? If you're new to JavaScript, you're not going to get the best out of a game engine. Game engines are hard to use, yeah? They're complicated, sophisticated things with a lot to understand and process, yeah? They're not going to just give you things straight out of the box. And you're also not going to get marks for adding 3 lines of code to a game engine, yeah? If you're using a game engine, you're going to get the marks for what you can deliver with that game engine, not for just copying the game engine example code, yeah? Another reason, so if you're new to JavaScript, you're probably going to find it hard to use a game engine. It's not going to be easier to use a game engine, particularly since I'm not going to give a lecture on using Phaser, for example. Second thing is, the main reason I've given you a game as coursework 1 is so you get better at programming JavaScript. So if you write, let's say 1,000 lines of JavaScript to produce a nice, version of Tetris or whatever, as I've seen students do before, then you're going to learn a great deal about how to use JavaScript. You're going to become a good JavaScript programmer, and that's going to be far more useful than being good at using Phaser or something like that. So the main reason you've got this coursework is to get good at JavaScript. So my personal recommendation is, unless you is to just use JavaScript, build a game based on the limitations of the canvas as it comes, and you can build a nice game with that. And I've seen some very nice games built just like that. Yeah. On the other hand, if you like the idea of maybe moving into game programming, as a career or something like that, you want to try it out, then by all means use a game engine, but just only take that step if you're feeling pretty confident in your programming skills. Yeah. And we can give you some advice about that in the labs. Okay, so just to show you the power of these things, let's have a quick look at a couple of demos here. So here's Babylon, yeah? So these are Babylon's demos, which I'm guessing are these videos. This is actually a video, but it's showing you the kind of things you can build in Babylon. I don't know about, so you probably get some demos that are actually real game engines here. Should never really do this live. But anyway, so now it's loading the game engine, yeah? With a bunch of, whatever. Is that it? Okay. So let's put it this way. Yes, let's assume that using Babylon, one could build, some really fancy graphics. So this is a sort of 3D graphical environment, right? And you've got kind of lighting handle for you. And if you look at this castle one when it comes back, you've got kind of the physics as well, yeah? So again, if we could find the examples working, don't know why I can't get the marble tower working. That's a bit weird. Maybe it's just taking forever to load, yeah. Oh yes, loading assets, please wait. Yeah, okay, so, oh yeah, there we go, yeah. So this is, in fact, being rendered within the browser, and if we wrote all that kind of hairy code, we could get our own castle game with marbles sort of dropping off it as well, yeah. So you can see the incredible power of these game engines. Yeah, if you wanted to do that from scratch using JavaScript on the canvas, it's going to take you a while, guarantee it. Yeah, and this code is non-trivial. Yeah, we've got 200 lines of Babylon code, which you've got to understand. All this kind of reflection textures, blah blah blah. Not easy, but you can do some really fancy stuff with it. Yeah. So Phaser is a bit less kind of fancy. Yeah. So and might be easy to use. I don't know. I haven't tried it. Yeah, but you kind of here we've got this kind of space invaders, and you can fire stuff, and it's it's got all that. So in this case, Phaser's probably going to give you some stuff if you use it, but also, given what I've just told you on this course, the game engine's not giving you many advantages with space invaders, I wouldn't say. You could easily write, I reckon, this Space Invaders game with 500 lines of JavaScript code on the canvas. You create your little aliens in Inkscape. You have some kind of model representing the positions of the aliens and just use that to draw the images. This background scene is pretty easy. Each time you clear the canvas, you just move the image slightly down. So this Space Invaders, you're not gaining much with Phaser, but things like if you're doing some kind of Super Mario type thing, you probably would gain something, yeah? Okay, so the CSS animation in JavaScript is covered in the modern JavaScript tutorial, probably pretty well since I like this tutorial, as you probably guessed by now. And then also we've got the HTML5 programming has a section on the canvas. Again, ignore the horrible vars they're using because it's, you know, way out of date, this book, but it has got a good section on the canvas. Example code is all available on the course website. Again, if you hand in Whack-A-Rat as your game, you're going to get 0. If you create your own version of it, if you use that as a starting point for your own game and produce something new, then we can give you some credit for it, yeah? So the crucial thing is here is you're welcome to adapt this code for your coursework, not just hand it in as your coursework, yeah? Seems pretty reasonable, yeah? Okay, so in this lecture, I've explained how you can add animation and graphics to your web pages. Obviously, that's useful and essential in a way for your game for Coursework 1. Well, not essential if you're doing a quiz, but useful if you're doing something more sophisticated and fun. But also, this kind of animation graphics, the stuff is super handy for, you know, transition effects, anything that, you know, like slideshows, drop-down menus, whatever it is within the web page that makes it dynamic, that's done doing this kind of technology.